And I just want to thank Westpac for supplying us the venue and food and drinks. And I will now introduce our two speakers. Yami Kondapatori is a platform engineer here at Westpac, and prior to here, she was working at the warehouse group, and we stole her. So she's doing some really good work here, building pipelines recently, and today she'll be introducing us to Docker. And our second speaker, McCallum, he is a principal build architect and has worked with Westpac for many years. He has over 19 years experience commercially with Java, hosting, and web technologies, and contributes widely to open source tools, and he'll be talking about Maven tiles. So I will hand it over to Yami.
Hi everyone. Good evening and thank you for being here. I'll do my best. This is my first meetup. Cool. Before I start, I want to start with a question. How many of you have already worked with Docker or Okay. Nice. So, what do you think Docker and what does contain? Anyone of us start with that? What are containers? Okay. This is it. So containers are isolated execution environments, and in other terms, people do call it as a jail, it's its zone, and it's the virtual environment, and it's very isolated. And Docker is an open source containerization platform, which is majorly used for all the companies and all. So yeah, we will discuss about what in detail in our next class. What is it before Docker? Yeah. So before Docker, we used to use bare metals. It's a hardware, and on top of the hardware, we have an OS, and then we need libraries according to our requirement for the applications, and on top of it, we used to deploy applications. So the problem with that is, if we want to scale our application, we have to start bringing up another bare metal or other physical machine, which is really not an ideal case. And that definitely increases the cost, that definitely increases much more work. So then we came up with the virtualization. So this is better compared to this bare metal thing, which is like, we will have a hardware, and on top of it we'll have a hypervisor that's like a software installed on top of hardware, and then we will have a VM. We will do the hypervisor will help us in virtualizing, and then on VM we will again install OS and required libraries and applications. So if we want to scale this, what we will do is we will install another VM, and on top of it an OS. This is good, but not ideal because it's still time taking, because we have to again install OS and all the configuration which we have. Then comes containers. So we have a hardware as usual, and on top of it, and then an OS, and on top of it, containers. So containers will have libraries and application. So though we have OS underneath, so we can use we will always use the kernel and the OS things from container. So whenever we deploy a container, we doesn't really install all the OS. We just use the underlying OS, and that's how it works with the containers. Benefits of containers? It's quick because we don't need to buy a bare metal, we don't need to go and install a OS, we really don't need to spend so much time on this configuration and all, so that's so quick. It's consistent because previously we used to have a problem like, okay, the application is working on developer machine, but it's not working on tester machine. That's definitely a known issue. It is consistent because we already packaged the required libraries and we containerized, and if we pass the container to other testers or the container developers, whatever their OS is, whatever the machine is, the containers, if they run their application using a container, it will be same on any machine. And it's simple because there's not so much work involved in it. We don't need to go after other teams to look up, like infrastructure or the other teams to look after it. So it's simple, we can do it by ourselves, which is nice. Use cases, as I said, it definitely solves this dev and prod parity, like dev machines. If developers definitely, if they write a code, it definitely works on the machines. But if we use the same code on production environment, sometimes it differs because of the like hardware or the OS. But in this case, containers, whatever the hardware it is, whatever the OS it is, on developer machines or also on prod machines, so it will stay. And it's easy, as I said, if we pass the container and if we give the container to the other developers, it is easy, and it's also easy to migrate from our physical machines to a cloud host, so it's easy to migrate. And it's microservice based architecture. Previously, if we want to install an application, it used to be a monolithic application. All the services, UI, DB, and all the things will be in a one machine. If we, like now with the containers, what we can do is we can actually run the services in containers. So it's like most like a microservice. And elastic architecture, as I said before, we no need to run all the services in one machine. It can be run as a different containers. If a UI requires more resource and if DB doesn't require more resource, we no need to both keep together and give a more resource. We can actually give more resource to DB and we can actually run UI according to its resource. It's a self-healing architecture. So if we pair our containers with orchestration tools like Kubernetes, so if the application is down and it couldn't come up, it will take it down, scale out, and scale in. And also, if we tie up with the monitoring tools, it will always monitor the CPU RAM usage. If we require more CPU, it will definitely give a scale out, and if it doesn't require the CPU, and it will scale down. And it's good to use in CI/CD pipelines. Okay, so a little bit of how we do it. So I'm using Docker here, and I'm just, so Docker ls is to list the containers running on my machine. Oh, sorry, my mistake. So that's the command to list the containers running on my machine. As of now, I haven't got any container. So I'm just running the hello world. So this is the Docker first image everyone runs. It makes sure that the Docker is running. It will give us an information, and that's the information. If we run it, it will firstly show us that our installation is all good, and it generates a message about this on how Docker does this work. When we run a Docker container, what it does is a Docker client connects with the Docker daemon. And if at all, if I don't have a hello world image on my local machine, what it does is it will pull the hello world image to my local machine from a Docker hub, so which is open source one. And then the Docker daemon creates a new container, and that runs the executable that produces the output you're currently running. So this is the executable. Whenever we run the hello world, this is supposed to be shown as an output. And then Docker daemons treat that output to the Docker client, which sends it to our Docker. So Docker, basically this is what happens when we run any container. So this is just running a container. And if I see list of the containers running on my machine, it's still nothing. It's because when we run a Docker command, Docker run, what it does is it executes the command which we have given on the image, and it stops the Docker container. So that is the reason we still couldn't see the containers running on my machine. So if we want to see the stop containers, that's the command. Yeah. Those are the containers that run after. This is the one I just ran a minute ago, and that is it. Okay. So if I want to see what are all images I have on my local machine, that's the command docker images. If I want to interactively log into a container, image. So it's like docker run and -I is interactive, P is a terminal, and I'm just trying to execute into the image Ubuntu, and I'm giving a shell bash. Okay. So I'm into the Ubuntu container, and I can actually run Ubuntu commands. So my machine is a Windows machine, but now I'm using Ubuntu OS. That is. So my OS is good. Just please. Yeah. So the other thing is now when we run docker run -it with the interactive shell, when I exit from it, the container stops. If at all, if I want to run that Docker container, so we have a command as a docker run -d. -d is a daemon, so it runs in a backend. So when I check what are the containers running on my machine, oh, sorry, I'll get rid of it. There's a container running, and it's running behind. Even though I can exit from here, it still keeps running. So if I want to stop the running containers, docker stop is the command. I run docker stop and give the container ID, and I stop it. The docker container stops. So the other interesting thing is if I have an Nginx, image, and if I want to do a port forward, I can do that. So what I'm doing is I'm just running a docker run. -p is a port, and 8080 is my local machine port, and the 80 is a Docker container port. And when I does this, and then I go to my browser, local host. So I can see that Nginx is running on my machine, and if I see on the port 8080, I can see it's running. So that's how we can also run our application on our local machine, and then we can see how it's working. I think that is it. So is there any questions on it? Thank you.
Can you go back to the slide, the last slide before you started? No, about the attributes. Yeah, here. The microservice-based architecture. Can you elaborate on that, please?
Yeah. So as I was saying, if we previously it used to be a monolithic application. So we are Yeah, as I was saying, it was a monolithic application. So what happens is whenever we run all the services in one machine, so if we want to increase the resources of a DB, and if DB requires a more resource, in order to increase the resources for the DB, we also have to increase the resources for the UI or other services because they all are running in one pod kind of thing, one machine. So if we run it as a containers, it runs in as a microservice. Each container will run differently. So DB will be running in one container and UI will be running in other container. And then if we want to actually increase the resource of a DB, we can just increase the resource of that particular DB. We don't need to increase the resource of other services, UI or other thing. So that's like a so we are dividing each service as a small microservice and running and managing it. So it's also easy for scalability.
Thank you.
You go back to the VMs and the bare metal VMs and containers. Yeah. So in that case, for example, right now we are using like a hypervisor. For example, in the case that you have like a different say clients, and every client has like a different VM right now with a very similar software. How do you migrate that onto a container type?
So what if the client?
For example, I have one VM for Westpac, and I have another VM for
business
yes, and so another business, but they have like similar software. For this example, a web page, and well, it's not a web page, more like a software, and right now they are managing everything on their own VMs. So that doesn't work going to containers, like having a container for one company and another container for another company, another container for another company.
Yeah.
Using the same basically ports and things like that.
Yeah, if we okay, so what's the question again?
Yeah, so we migrated from a virtual machine architecture to a container architecture.
Yeah, so when I say they are like isolated, they are different. Even though they are running on the same machine, they are isolated. So they are different containers, like they are in a different namespaces. So
on the software layer, I understand. But for example, for managing the connection, I want to connect to a specific container instead of connecting to another container. Normally, I have a DNS name. And they connect to one computer and one IP address. And they connect to another computer with a different IP address. In this case, how do we manage that network layer?
Docker will have a bridge network. So that manages the network, and every Docker container runs on that bridge network has their own IP. So if we run a Docker inspect command,
so you will need to route internet to that container.
So that goes to the internet. No. Actually, that goes to the private network.
Private network, yeah.
Yeah.
And I want to use like a private network run, routable network run. This have my network in the same space. I mean, they normally would give you I think 172 or 192 something like that.
Yeah.
Or if I, for example, use 10.58 or something, and I want it to be like in the same 10.58, and I actually want another 10.60 something or 10.17.
We can assign a DNS name for the Docker containers.
So I will go more than like in the network, because if I have like a different clients, I will have like a different network connections. So I want to share the connections.
Okay. I'm just confused.
I think in a way that what we're talking about is Docker is runtime, and the Docker containers just run the runtime. But what you're getting at is probably more of the Ingress Kubernetes side of the world on how to orchestrate Docker containers and stuff like that. It's a bigger topic, probably the master bit is my idea.
Yeah, I mean, like if you want to manage a container, there is an orchestration tool, as I said before, that's a Kubernetes, and that will have an individual namespace, and that will have, if we use an ingress, it will have the DNS name and all, and that will not be accessible to the other. If we host the Docker containers in one namespace, of one business, and we host the namespace of Docker containers of other business and other namespace, we can actually stop like connecting. So we.
Sorry, we have to sharpen the a little bit.
Hi, Michael. I've been doing development for quite a long time. You're reading my LinkedIn. It's good. So thanks, Committee, for your intro into Docker. I'm just going to follow on sort of at the same kind of level in terms of the low level with Docker and running it, but from a Maven perspective. So how do we tie that into a Maven build process where we're running Java applications and other things? And how, if we get time, talking about skinny pipelines and building a bit of a deep dive into tiles with Maven, how to optimize Maven build process. So Docker and Maven. There's three main plugins that are available at the moment for using Docker from Maven. There's the Fabricate plugin, the Spotify Dockerfile plugin, which has changed. It used to be a Docker Maven plugin from Spotify, but they deprecated that in favor of just running Docker files, which makes some sense. And you've got the Jib plugin from Google, which is more of a Java-based optimized Docker image build that does optimized layering. My preference is generally the Fabricate plugin. It's quite flexible. It gives you the ability to either use a Docker file, so you can write Docker files if you understand how they work, and you want to have custom things that do unusual things with them. Or you can easily use the abstractions in the Maven definition to run and generate the Docker file in the background and then reuse it. You can take it across a number of projects. And it gives you a bit more flexibility, also in terms of running it. It lets you run as well as build. So you can run, you can release from the Fabricate plugin where with the Jib Maven plugin, you only really get the ability to build, you don't get the ability to run. Yeah, good support for just running. The documentation for Fabricate is really, really good. So there's loads of documentation. It's lots of examples. It's really well laid out. There's regular releases, so they keep it up to date, especially with change Docker with it. The API for Docker doesn't change as much anymore as it used to. One of the other things that I really like about Fabricate plugin is when you're building the Docker image, it lays all of the stuff that you're putting into the Docker image out on the disk. So when you do the build, you can see what's going into it. So you can have a look, you can inspect it, you can then run the Docker image, have a look, compare the two things, which is quite good. Whereas with the Jib plugin, it's doing an optimized process of effectively dependencies, builds them into a layer, and then builds your application on top of that. And when you try and look at that on disk, all you get is the hashes. So it's like you're looking at the Docker registry, you can't really inspect what's going on. It's very big. So you can run it, but you can't see what's in it. The Jib plugin also, because it's optimized to generate layered images that are clean and fast and it's cached, which is nice that it's fast and it's cached, but it doesn't produce Docker images against the Docker daemon, which means that if you want to run it locally and test your thing that you're building, you can't do it. So you have to, if you want to use the Jib plugin, you have to build it twice. Once for something that you're going to build and push for a remote registry, and once locally in the Docker daemon, which ends up being two different groups, which hopefully are the same, but they could be different. And so, where we use the Jib plugin, which is nice because it's fast and it does the nice layer, and then we build it twice, and then we test the second image and assume that it's the same as the first one. The documentation isn't great. It's kind of a Google project. They do good bits of documentation, and then there's like gaps, and sometimes you have to try and figure out what they're doing, and then if they make big changes to stuff, which they do, it kind of gets out of date, and so you've got to make sure that the documentation that you're looking at is the latest documentation, so you get quite confused. The Spotify plugin, I don't use it. I looked at it ages ago, it didn't quite work, it was a little bit hard to use. And I think the original focus that they had was on very much we're building a Maven plugin, we're going to do it entirely in the Maven way. There's no Docker files, you have to use our abstractions. And they quickly found that actually it just doesn't work all the time. And so then they had to break the case. And then they moved entirely in the other direction. They said, actually, we're going to abandon that entirely, and you always have to write a Docker file. And then you lose the ability to generate Docker files and share them across your projects for use. So both still exist on GitHub, but only the later, the Docker file program or something. And I've got some examples. So the first example will be similar to the community example of Nginx, where we just need to run md and clean verify rather than running Docker build and Docker, rather than running Docker build, which you didn't actually show us the next time. This will build an Nginx container which contains just an HTML page. It's an HTML page. Key things to note is that we use explicit paths, so if you're building the Docker container, which is essentially a file system, right? It's rolled up into a set of tasks, but you've got a file system which is rolled up. And if you're looking at your project on disk, you want to make sure that the structure that you see on disk matches what's going to be in the doc image, so that if you're running a doc image later on and you look at it and you find some content in it, be it source code or something that you want to change, when you go back and look at your projects, the paths match, you can find it easily. You don't have to search and say, oh, I see there's a rule which says take this file and this file and this file and this file and put them together. You don't have to undo that 12 pieces in your face. Also, it's important to use explicit versions, so if you're building from an Nginx container as a base, you don't want to use latest. You want to say, I want to use version 119.0 and 119 in Alpine, because that's the version that I want, and I want to make sure that if I build it again, I get the same thing. But I want to get 120, because they might have a breaking change, which does happen. Experience that. Alright. Can you guys see that? Should I make it bigger? So, does everyone use Maven? Who hasn't used Maven? You haven't used Maven? Never?
Well, I'm from a .NET background.
Oh, right, well, sorry. That's my mouse. Okay, let's start at the top there. So the benefit of using Maven is that it's a conventional system, so it forces you to, and no one else put their hand up, I'm assuming that everyone else uses Maven. Use Maven?
Yeah.
Okay. I'll do the basics. So the benefit of using Maven is that it's a conventional approach, so it forces you to work in that way, right? And be declarative, so you define your project up front, you declare what you want it to be structured like. So you say, in terms of the format, it forces you to use XML. If you really want to use YAML or JSON, you can use Polyglot Maven and do that, but from my perspective, JSON and YAML and XML, they kind of look the same after you've done it for a few years. You can't tell what's doing it. It's just data structure. So there's a very strict format for what you can do. You can't do arbitrary things. So like Gradle or Ant or Make, where you've got kind of a free form, I'm going to program my build process. Maven says no, there's a rigid structure for how you do it. There's a life cycle for how you build a project. So the POM table references to the fact that the project object model, or POM, which is the basis of Maven definitions for projects, what I'm talking about is taming and making them, which obviously it's quite long. There's a lot of detail in it, and this is a simple one. So build is complicated, so POMs get complicated. So we want to figure out how to manage that. So the key things that you get in the project object model is that you want a very clear name for your project. So, everyone can read this? So you want a very clear name. So the name for a project is the artifact ID, and that's something that's within the scope of the group. So the group is like the namespace for a set of artifacts, and the artifact ID is the artifact within that scope. And you always have a version, and you want to have a packaging type. So what am I actually making from this project? In this case, it's a jar. Well, it's not a jar, because we're actually making a fucking make a jar. And there's a version, because it's strongly typed in terms of the definition, then there's a version for this, which is 400, which has been 400 for about 15. So it's pretty stable, right? They haven't had to change it. And then there's a name which is, I always set it to the same as the artifact, but you never needed to do it differently. Some circumstances where maybe you do. Description, inception, yeah, there's a whole bucket load of metadata you can put in there, like URLs, licensing, committer lists, collaboration lists, where you find the source control, how you manage that. So you can include all these things and generate documentation from it. And there's a lot of plugins for the site plugins that lets you generate type parameter. But the key thing really is that off the back of this, you've got a model for when I say I want to build this thing, what does that actually mean? And built into the default lifecycle that you have is a Java project, because it's Java based, and that you have a sequence or the lifecycle of how you build a project, which is I've got resources I want to generate, I've got code that I want to compile, I want to test that code, I want to package it up in some useful way, I want to run it, and then when test against it, shut it down, and then I want to verify that my tests pass it and it's good. And then after that, if I'm in a state where I want to be releasing or to promote it somewhere like to Nexus or Artifact repository, then at that stage I'll do it only after I've passed all of those stages. So that's well defined and it's built into it. And so the way that's realized in Maven is that you have plugins which are attached to lifecycles. And so they've got a very strict definition in terms of what they are. So you've got the build lifecycle that you have and a set of plugins which are defined in the same way as this project is. So we've got the group ID artifact ID version. So if we say I want to attach a plugin to some part of the lifecycle, then you define the group ID artifact ID version of the plugin. And that will attach this plugin to a lifecycle in some way. So plugins have modules, which are Maven or Java objects, which are essentially just a class, which has a name. So in this case, we've got a mojo, which is part of the Docker name plugin from Fabricate called, and so the goal of running this plugin here is to do it. And so that will run a piece of code. And that's attached to the package space. So when we've done our generating of resources, our processing resources, our compiling of our parsers, then we want to package it up. By default, we've got a jar package, so it'll package up in the code we've written. And then the next stage is it will package up, it will run this Docker build, and build a Docker image as part of the package space. And then we've got the configuration for it. So this is the information of the build goal in the package space with some configuration that we have. And in terms of the images that we're building, so we want to build a Docker image. So that block is the definition of the Docker image that we want to build. So in this case, we're going to build a Docker file. So it's a handwritten Docker file, and it'll just run it. So it's just going to run it with a Docker daemon. And a big part of something that's standardized in Maven is the concept of an assembly, which is essentially a common set of rules for defining how you aggregate a set of resources, be they files or artifacts or archives from things that you've built, how you aggregate those together and make them into a meaningful output. So in this case, we're building a doc image. So this says, take from this project everything in source bank HTML and put it into the base folder that we're going to output, and I'll show you a second what that looks like. Only include HTML files, don't want anything else. Text and file notes, don't mess with the content. So you can do filtering if you want to do filtering, replace the project name with version of other things with your HTML, you can do that. So that's the basis of that, and this essentially will run Docker build minus T name, if everyone is familiar with Docker on this Docker file. Essentially, that's what it is. A little bit complicated. But file mode, that's setting the permissions. So 0644 is the unit file permission. But that'll mean that in the Docker image, the owner of the file, which will be Nginx, probably, will have right permissions, not anyone else will have.
Is that an actual Docker file or is that something that gets generated?
No, this is an actual Docker file. I was going to get that in a second. Are there any other questions for this one?
Are those tags from the plugin?
Which tags?
Those like a output directory or some Docker.
Yeah, so this, all of this inside the configuration here, all of this is for the plugin. So if you're using Eclipse, it's really easy to write these because of what it completes. Not so much in the IntelliJ other things. So if we want to look, so looking at the source for this, as I was talking earlier when I said that we use explicit paths, so it's very clearly laid out here that if we're running a standard Nginx Docker image, then it sticks its HTML into user share Nginx HTML. So that path is here. So what will happen when we build this is that we'll put that index file and we'll overwrite the default Nginx one. Just so it can show up. And we've got a Docker file. Yeah. Very simple. So from the Nginx 1.9 pipeline, copy the things that we've aggregated with Maven into slash, so to the root directory.
What is the command in that file? The command or the entry point?
Doesn't have one because it's inherited from Nginx. So it's just the default running Nginx command. Don't see what it is. Where did you find it? So build the image. Let's just quickly. So when we're talking about the life cycles, we've got clean. Yeah, we've got the generating of the resources. We've got compiling test resources, test compiling, writing tests, building the jar, building the doc image. There's a couple of flags there to make sure that when we build the doc image, we actually print out what it's doing, so that we can see, which is useful. So we're talking about changing context and going from Maven to execute something into Docker Daemon. So it's useful to see what's happening, especially if fails. Something goes wrong, you get error messages. Outline for you. And we can run this. And so that's running. Got it. You can see it comes back with hello. Look at.
So when you actually ran the Maven build, can you just have a look at the entire tree of where you are? So just where it actually created it. I sort of put everything into target directory just like normal Maven project.
Yep. So what and this is one of the reasons I really like fabricating Maven plugin is it creates this Docker and then the full name of the Docker image, and then it lays it out so you can see when you get the Docker file and set copy Maven, it's this folder there. So everything inside of there is what ends up in the Docker image. So you can just say find and you can see exactly what it's done.
Okay.
So it's just right there for you. And in the situation where, and I'll show you that next, it generates the Docker file, it just generates it, so you can see the Docker file, it generates it completely.
So when you say that the file system on your local and what should be the Docker image, it's basically everything after that, after the Maven project.
It's exactly like that. So it literally just takes this and it copies that into a new layer in the Docker image. So then it's very in your face. You can see it immediately, you can look at it, you can understand it. Like if you were to go and say, I'm going to write my Docker file and I'm going to have my index HTML, I'm going to put it here, and I'm going to stick some CSS, and then I'm going to stick an image all in the base, and then in the Docker file I'm going to be clever and I'm going to copy them to various different places, like in subdirectories. Then you look at this and you see a flat structure, and then you look at the Docker image, it would match. And so if you were to find that Docker image in the wild on the server, you look at it and you're trying to diagnose something, and you look at this project and you go, they don't look like the same project. Am I looking at the right place? So try to keep them consistent. What's the time coming up? So, this one is the same, but it's not using the Docker file. The only difference is that I've dropped out the Docker file reference. I've added the from in here, and I've got a target directory, which is that slash. So that copy Maven slash, that's the target directory. And if we put it,
Also, that copy Maven slash is implied.
so we don't have the Docker file, you have to reference it. So if you don't set the target there, then it will default to copying that with the slash Maven in the base of the document, which isn't very useful. And so if we look at target now, we can see that we have a Docker file which looks remarkably like the other one, but it was generated by Fabric. And And so, I mean, there's not much of a difference here between running with the Docker file and running with Maven in this case, right? Really, Maven is still similarly complex. But the power comes from when we go to the next stage. So, switch back. This stuff is all working out, by the way. It's all much more useful if you have tiles and you want to reuse the snippets of your Maven configuration. So, Maven's been around a long time. It has, oddly for a Java project, it has a strong inheritance model and it doesn't cleanly do composition, which is Java's all about composition and doing inheritance nicely. But some years ago, someone said, hey, we can simulate that as people do by using the parent structure, and we can simulate multi-inheritance using parent. And tiles is essentially multi-inheritance in Java, where you can say, I've got another snippet of POM, I want to merge it into my project. And so you can do this manually by creating arbitrary complex parent hierarchies and inheriting things that are very complex to manage, and you lose a bit of flexibility in terms of being able to say, I want this little bit, I want that little bit, and I want that little bit to run my project. And when I say that little bit, I mean, if I say I have a project and there's a Spring Boot application, so do Spring Boot things, and I want to make a Docker image out of it, and I want to make sure that I run integration tests against MySQL database. Those are three things that you might want to do. You might also have Postgres databases and Micronaut and Quarkus and all these other things, and if you had the cross product of those in terms of the parent hierarchy, obviously it's a massive hierarchy to maintain. So Tiles makes that easy. And some friends of mine in Auckland picked up a Tiles plugin that was built by someone random some time ago and took it to the next level, and they're actually really useful. You may have seen them around Mark Verica and Richard Bowles around the world, and seen meetups and stuff. And it's really good. So that's the Repaint IO project. It's a Maven Tiles plugin. It's just a plugin. with an extension of this and fancy thing. So what are tiles? Small units of Maven configuration. Most Docker plugin configuration properties. It's a bad idea to use dependencies. There's better ways to use dependencies than Maven. Don't stick it in the don't stick it in the file. They have their own life cycle, and what that means is that if you're releasing a tile, it has its own life cycle. So you release it, it gets published, and then you release it. So it's got its own life cycle, you can version it, if you make those changes, you can version of it, and not bring all those versions. And it looks just like it's on. It's just a kind of consistency with some things that you can't. So trivial example, similar to what we were showing earlier, we've got a plugin definition. This is the Java plugin, so standard definition of the project with a little bit of configuration here, turning off the Maven descriptor so we don't get dates generated into our jars, which don't need to be. So we could go and stick this in all of our Maven projects, and if you're using microservices and various other things, then you're going to get this configuration in 500 times across all the microservices. Maybe not 500. 370 average. There's obviously a lot of boilerplate that doesn't actually do use anymore. Don't do dependencies. It's bad. But we don't have time to talk about that tonight. It's a long conversation. So why use tiles? To reuse the configuration to allow you to test your plugin configurations. So because you've got your own lifecycle for the tile, you can wrap up plugin configuration and you can actually run a test on it. You can run it with, and you can try it and make sure it works correctly, and then you can reuse that tile for products after you test it. Saves you rolling stuff out or sticking it in parents, and we've got a relationship between one project and a parent. It's a strict relationship. You can't use version ranges, so that means that if you want to roll a version out, people have to pull that change in, and if you make a mistake, hey, you don't realize until after you make a whole change to all the projects, and then it's broken, and then you put changes. There's a lot of changes involved in doing that. You don't have to fix it all, just automatically roll change out. Makes it easy for new artifacts to be created. If you can just say, I want a new project, I want to pull in these tiles, I'll show you an example of what it looks like. Then you can just say, I want to have a Spring Boot application, I want to make it Docker, I want to include Kubernetes configurations. 3 lines are done, it's ready to go, add code. It also means that if you're looking at the definition of your projects, and if you're looking at build scripts and all of these things, if you're looking at build scripts, it's quite hard for a new developer to come into a team, and if you've got big Gradle scripts and big Ruby scripts and all these things, trying to understand what's going on in the build process and how that works to make something that's useful, that's a massive overload, let alone trying to understand the business and what the business needs and how to write the code to do. So what you get with tiles is that you get this very small definition, and so you see that this problem is very small compared to the one that I showed earlier, which was running a building block and running. And the cognitive loaders are doing some building and doing some testing and running it. And so from a new starter, you can look at that and you go, okay, I don't understand what those things mean, but if they've got good names, I can go, okay, so it's doing some Jib stuff. And I can just run it, and it'll work, and if it works, it should work. Because it's been tested, everyone's using it, and it's free across the projects. Then you can say, I can understand that later once I understand the business domain. So I can do that, and then you come back later and go, okay, what's this Jib thing coming? You go and look at it and understand. And so the way that you use tiles is you just include the tiles pane. You reference the tiles for the care, so the group artifact. So this is the alternate syntax from what you see in dependencies, and this is more something like what you see in Groovy or leading it or 2 minutes.
Can you version those tiles?
You can version tiles. 2 minutes ago. I'll talk about that. So how tiles work? Like I said, it's Maven single inheritance, but essentially the tiles plugin synthesizes a parent hierarchy. So what it says is it takes those tiles and then it creates some and it lays them up. And so you get a nice hierarchy where the pieces of the POM are incorporated and merged together. What does it look like when it runs? So the tile tiles plugin tells you what it's doing. So it says I found one tile that sits in the middle, I'm mixing it in, and it tells you exactly the stages that it's doing. It says this is the tree of parents that I've created from this tile, so you can go and look at them. It tells you the versions that it's resolved. You can see on that side 114 and 104, so you can go and look up the explicit versions that they actually use in that version. See them as a page. So what you want is when you're running it, you want to actually see what's going on. So it's useful if you write a file so you can see what's going on. And so in terms of configuration for stuff, rather than hard coding values into the configuration of your plugins, if you set properties and set default values, then it gives it the opportunity as a developer later. So actually, my application needs more memory. And so you can use the standard tile and you can say I need more memory. And it's good to have the configuration, we want to see what it is. So we use the Maven plugin, and so at the beginning of the build process, we print out that configuration. So you can see these are the configurations that are being used, and if you want to override them, then you just need to set these properties in your form. And so it looks like this when it runs. And so it says the port is 80, the container is 80. I'm using 1 GB RAM, 100 millicores of CPU, maxing out to limited to 2 CPUs. Tiles shouldn't be composed, so if you look at dependencies and movements, often useful to compose them together. So if you've got, say you've got lots of Spring Boot applications, you don't want to include all the Spring Boot dependencies in each of your columns for each of your projects, but rather you want to define one definition of when we use Spring Boot, we need all of these libraries together. Lifecycle that's similar to the file, but as a Maven project, and then you include that in each of your projects. So that's composing stuff together and strangling the definition of those libraries in one place. With tiles, you don't want to do that. You want to aggregate them together. And by that I mean that you're not strangling them, but actually you're setting a rigid definition of what tiles explicitly you want to use. And so so this is a tile as opposed to a POM. So this tile concept here is not based in the POM model. It's something artificial that's agreed by the tiles Maven plugin. And what it lets you do is it lets you say this tile is made up of these two other tiles. So it's free form, you could mix and match this with other plugin configurations, but I recommend that you never do that. If you're going to do an aggregate of tiles, then you should only do it in a specific tiles for that purpose, and all it does is aggregate. So if we do this and we use a version range, then when you're reusing this tile, then you're going to resolve that version range at the build time of your project, not at the build time of the tile. So when I say aggregating the tiles, it's more important to actually resolve, when you build the tile itself, resolve the versions of those tiles that you want to pull in. And there's a plugin that I wrote a long time ago that essentially just looks up the new artifact store and resolves an artifact name to a version that sits properly in your environment. And so here the tile XML looks very similar, except that we've got a property thing. And so the build time to resolve that, we're replacing the tile when we release it. And what that means is that for a given version of the release of the tile, those versions are fixed. So as a developer who's using these tiles and putting them in, I can always choose a specific version. And if something goes wrong, so someone releases a new version of, say, Java 11, and they accidentally put Java 12, they broke everything, you'd see that when you were building locally, go, hold on a second, I've got Java 12, you could roll back to the previous version by that. I could just lock this version here to be a fixed version rather than a range, and say, actually, I want the previous version, I don't want the latest one because it's broken. Go and harass the developer, break it, get them to fix it, and then when they fix it, you can open the range. So you've got full control about what's happening, and you can rock and roll it forward and back as needed. Minus 5 minutes. This is the last page. I chopped the rest out, so I didn't gotchas. Some properties aren't available for POM interpolation, so there's certain properties in Maven that are special, and you can't use them and you can't set them. And you'll find that out the hard way. I forget the list, and I always find it that way. Tiles and tiles, as of version 117, are always after the locally declared tiles. So if you have aggregate tiles, then the ordering that happens means that they come last. If you're running the latest version, 1.10 and above, they're always been reversed because it makes more sense. Which is good, but I haven't upgraded yet, so it has an impact. When you're writing tiles, because the ordering of the tiles when they get merged into a tree affects when plugins run, it's really important to set your phases correctly. So if you need to do something in package, make sure it's in package. Don't stick it in test. Don't stick it in pre-execution test. Make sure your packages are sensible for what you're trying to achieve. You can't add Maven extensions in tiles because of the point in time at which the tiles get resolved because of the extension. It's too late. You can't do extensions. And tiles can be opaque if you're not chatting, if you don't log stuff, then it's hard to organize things. Questions?
Any questions? Can you see the output of like the full pond after if you use a bunch of tiles and then you want to look at what the full pond looks like?
Yes. Yeah. So I made a little example. So of the tile. So I took the example I showed you earlier, where I had the build. I didn't actually show you right, but he's running as well. I put that into a tile. Looks like this. So this is a tile, and the usage of that is here. See the example. So if we want to see what's actually in it, with Maven is a desktop plugin, and you can generate the effective POM of what would be resolved for the complete tree of all the plugins. And so we can see that, find some examples. So you can see here, part of the resolve hierarchy for this project is that I've got a resources plugin that's bound to the process test resources phrase, and it executes this way. So you can see all of these executions, so you can always see exactly what the project's going to do. And we should probably demonstrate what's one of the key things with tiles. Obviously, you can see there's quite a lot involved. So this is the post-integration step for stopping the Nginx container that I built earlier. And you see this ID that's been put onto this execution. It includes the full path of the tile that came from. So if you're ever looking at the execution of any plugin in a Maven build script, it will show you the ID of the tile it came from. So it's easy to go, why is this plugin running like it's from that tile? The other question.